Okay guys, here we are with the Wagon again. We've got it up on the hoist. Now we're going to start fitting our own 3.5 inch dump and front pipe combination. Now the car currently has a 3-inch generic front pipe, which you've seen from an earlier episode, bolted onto the stock dump/O2 housing. We are going to use our 2-bolt bolt-on front pipe. We're going to retain the 3-inch midsection with catalytic converter for now. Later on we will chop that out and bring it up to a full 3.5 all the way. But for now we are going to measure the effects of the simple bolt-on 2-bolt flange front pipe, which will allow you to fit your own catalytic converter or run it as a decat system for racing use only. Alright, so what we're going to do is we're going to get this one off. We're going to put it on the bench and do a comparison looking at the differences between the stock downpipe and our own one. And we'll also go into some of the features that ours have over some of the others on the market. Alright guys, here we are. We are going to remove this generic 3-inch front pipe which bolts onto the stock dump/O2 housing. It uses a 2-bolt flange setup. We will be switching it out to our 3.5 inch front section with our 3.5 inch dump/O2 housing. We will be having a 3.5 inch version all the way through to the original catback system, which will allow you to delete the catalytic converter for racing applications. Okay, so what we're going to do is do a little quick comparison versus the original equipment on Evo and ours. So here it is here. It's got a single O2 sensor. It's got a graphite based seal slash pivot or flex, cast iron. It has a split and then it merges lower down. If you compare ours is non-divided, so it's actually open. As soon as the exhaust gas comes out, there's no separation. We also provide a second O2 sensor mount. So for guys that want to run a wideband or add it themselves at home, there's no need to fabricate or take any parts off and weld it. You can just simply screw in a bung when you're not using it. Our outlet is 3.5 inches, whereas the OEM is about 2.25. All right guys, the original Mitsubishi design has a flex system in the downpipe. This allows movement here, like so. And then whereas ours, we've gone to a different style of flex, but also very flexible. Something that a lot of people leave out on their exhausts is a flex. So a lot of people get mixed up with expansion joints and other types of flexible looking couplers or joiners. By having a very flexible flex, it will stop fatigue happening on your exhaust system as well as your dump pipe or manifold. It'll help prevent that from cracking. So that's something that's very important, and we are actually going to do an episode specifically on flexes later on. Alright guys, so I'm just going to quickly show you the measurements here between dumps. So the ID of ours is 88 millimeters, and then you've got the OEM unit. You're sitting at 56 millimeters. So yeah, quite a sizable increase there. So on the downpipe or dump, you want to have as much flow as possible to reduce the back pressure over the turbine wheel. We're just going to quickly show you some of the differences between our 2-bolt flanges and some others on the market. So a traditional pipe is 76 millimeters or 3 inches, and that has a wall thickness of 1.5 roughly millimeters. So that gives you a 73 millimeter ID.
Can I see your ID?
All right, so I'm just going to quickly show our 2-bolt flange. It has an ID of 80 millimeters. The reason why it's called an 80 millimeter flange. that will be supplied with a matching gasket. So that will enable you to bolt it up to your factory Mitsubishi catalytic converter or any aftermarket mid-pipe. So these will all be supplied with the production versions, or you'll be able to order it with the 3.5-inch V-band. We will also be doing a 3.5-inch D-cat pipe, which will continue that 3.5-inch to the standard catback location. So you can fit your own high flow cat, or if you're a race car only, you can run it without the cat, depending on your regulations in your area. Now that we're going to start fitting our one back up, I just thought I'd go into a little bit about the O2 sensors and some of the features of our downpipe having the extra provision for another O2 sensor, either a narrow or wideband, depending on your application. All right guys, the car's had a fair few Ks on it and it's not exactly a spring chicken anymore. So we've decided to replace the O2 sensor since we are tuning with the stock ECU. So again, our system allows you to run 2 O2 sensors. So you can run the factory narrow band. In our situation, we're not running a wideband. So you just run a blank off in it, which is screws straight in there. But since it's nice and easy to reach, you can fit a wideband at home without having to take anything back off the car or without having to weld anything onto a front pipe or down pipe. So that will make things nice and easy as we fit it up. All right guys, we've just finished up the install. We've got the new O2 sensor in there. It's all wired in, and we've just plugged up the spare O2 sensor mount. So now we'll just get back underneath the car and show you what we've done. All right, it's all bolted up. It's the flex. And there's the 6-inch cap. Remember guys, the production ones will have the cast flange. As you can see from the footage underneath the car, this a 3-inch exhaust with a standard 2-bolt flange that has an ID of 73 millimeters, which we spoke about. So 76 millimeter OD, 73 millimeter ID. So our production front pipes, we have this cast flange, which has an 80 millimeter ID and matches up with the 3.5-inch piping that we have on ours. So it gets the absolute maximum amount of flow you can out of a traditional 2-bolt flange. So these will be available separately later on. So if you want to make your own 3.5-inch exhaust off that 2-bolt flange, that makes it quite simple. Alright guys, as you've seen on the dyno, it is absolutely ripping hard down low. It's totally transformed the car in terms of drivability. It just has a lot more response and torque down low now. So Mick was able to get the boost to go 27, 28 PSI down low, and it tapers down to 20, 22, 23 PSI. Since we removed the electronic boost solenoid before due to some gremlin, maybe in wiring, what we're going to do is we've ordered a TurboSmart boost controller that will be installed at Evolution Racing Spares, so we can try and get boost control higher up in the rev range again. What we found was as soon as the dyno's engaged, it's on 16 PSI and shoots straight to that 27, 28. The car has an immense amount of torque at the wheels. So with an automatic transmission, there's a multiplier going on with the stall converter. And so traditionally automatics, you can actually, it applies a greater amount of torque down low than a manual car. So We took the car down to New Zealand quickly for a drive, and we found that the car just turns the front tyres immensely. We are going to remedy that before we go to the drags. So whilst the car's at Evolution Racing Spares, they're going to do their little secret AYC software change to lock up their centre differential to try and remove that front wheel spin that's occurring. Another thing, we want to get the boost controller back on the car so we can get the top end power as much as we can. Now that we've removed that exhaust restriction, we want to see if we can pick up the mile an hour a bit more. So we are going to fit the boost controller, play around with the AYC programming, plus we're going to fit some brand new tyres to it, which will help, and we'll be getting it back on the dyno one more time before we hit the drags. As we said, it's pointless now. Before we were having wheel spin issues, as you've seen in previous episodes, we've discussed putting new tyres on it, but it'd be futile if we go back there now with the amount of torque that it has.